Hello everyone, this is Teacher Epoy, and I'm gonna be talking about polynomials. These are the objectives for this session. Identify polynomials and its parts, determine the degree of polynomials, classify polynomials, and write polynomials in standard form. Let's begin. Okay, to start with, let's have the different properties of a polynomial. So if I'm going to give you these two expressions here, the first one is a polynomial. The second one is not a polynomial. The second one is not a polynomial. Why? Because there is a negative exponent on the variable. Because the first property is no negative exponent on the variable. Why is it that on the first example, it's a polynomial? Since, naaman negative 3 there. So take note. 10 is not a variable. It's a constant. Look at the variables here. That's a positive exponent. And that is also a positive exponent. So therefore, this is a polynomial. This one is not a polynomial. Second property. The second property is no fractional exponent on the variable. So take note of this here. Because of the fractional exponent on the variable x, this is not a polynomial. Okay? This one is not a fractional exponent, therefore it's a polynomial. For the third property, you have noticed now that there is a radical symbol. Okay, property number 3, no variable inside the radical symbol. Okay, so take note, there is a variable inside the radical symbol, but I'm gonna change this to fourth root. This is the fourth root of x cubed. So take note, this is not a polynomial since there is a variable inside the radical sign. In this one, there's no variable inside the radical sign, therefore, this is a polynomial. This is not a polynomial, the second one. Property number 4. So take note of the denominators. Is there a variable here in the denominator? No. In our second example, there's a variable in the denominator. So property number 4, no variable in the denominator for it to be a polynomial. So take note of the rules. Number 1, no negative exponent on the variable. Number 2, no fractional exponent on the variable. Number 3, no variable inside the radical sign. Number 4, no variable in the denominator. There you go. So let's start with the monomial. A monomial is a number, a variable, or a product of numbers and variables with whole number exponents. So these are examples of monomials. This one. This is not a monomial since the exponent of the variable x is negative. This is not a monomial because it has 2 terms. A monomial only has 1 term. This isn't a monomial because there is a variable in the denominator. So the degree of a monomial is the sum of the exponents of the variable. A constant has a degree 0. Let's find the degree of the monomial here. For letter A, what is the degree? The degree is simply add the exponents of the variables. You have there add 4 and 3 to get 7. So the degree is 7. For example, letter B, add the exponents. You have 1 plus 1, that's equal to 2. So therefore, the degree is 2. For example, letter C, add the exponents of the variables. Take note, this is any variable. For example, you have x raised to 0. The exponent of the variable is 0. It's a constant term. So take note, a constant term has a degree 0. Take note of that. Now, let's have more examples. Letter A, what's the degree? Add the exponents. 2 plus 1, that's 3. So therefore, the degree is 3. 2 plus 1 is 3. In example, letter B, the degree, that's 1. Therefore, the degree is 1. The exponent is 1 there. For letter C, the exponent is 3. The degree is 3. It's very, very simple. If you only have one variable there, the exponent is simply the degree of your term. But if you have 2 or more variables, you need to add their exponents to get the degree. Let's have the different terminologies now. A degree refers to the exponent or exponents. When I say degree of a polynomial, it's the highest exponent. If the term has more than one variable, then add all exponents of that term. Coefficient, the number in front of the variables. This is I'm referring to the numerical coefficient here. Leading term, the term of highest degree. Its coefficient is called the leading coefficient. The constant term. The constant term, this is a term without variable. The missing term, the term that has 0 as its coefficient. Okay, let's have these examples. Let's find the degree of each polynomial. For letter A, find the degree of each term. What's the degree of the first term? The degree of the first term is 7. The degree of the second term, it's 3. There you have it. The degree of the first term is 7. The degree of the second term is 3. And what is the highest degree there? The highest degree is 7. Therefore, the degree of this polynomial is 7. Example letter B. Find the degree of each term. What's the degree of this, and this? I'm going to show you the degrees now. The degree of the first term is 3. The degree of the second term, how did you get 3, by the way? That's 2 plus 1. The degree of the second term is simply 4. The degree of 5, a constant term, is 0. Now, what is the highest degree? The highest degree is 4. Therefore, the degree of the polynomial is 4. Okay, let's have more examples. Find the degree of each polynomial. 5x minus 6. Find the degree of each term. The degree of 5x is 1. So take note, you have an exponent 1 there. And the degree of the constant term negative 6 is 0. So what's the highest degree there? The highest degree is 1. So therefore, the degree of the polynomial is 1. For example, letter B. Find the degree of each term again. Okay? So the degree of the first term, you add the 2 exponents, you'll be getting 5. The degree of the second term, adding the 2 exponents, you'll be getting 5 as well again. the degree of the third term, that is 4. The degree of the constant 2, if there are no variables, the degree is 0. Now, what's the highest degree? The highest degree is 5, therefore, the degree of the polynomial is 5. So, the terms of a polynomial may be written in any order. However, polynomials that contain only one variable are usually written in standard form. The standard form of a polynomial that contains one variable is written with the terms in order from greatest degree to the smallest or the least degree. When written in standard form, the coefficient of the first term is called the leading coefficient. Let's have this example. Let's write this polynomial in standard form. Let's determine the leading coefficient. So, first thing to do is find the degree of each term. Then arrange them in descending order. So, you have there the degree. So, the degree of the first term is 1. This one is 5. The degree is 2. The degree is 0. So, take note, it's 1, it's 5, it's 2, and a constant term 0. Then arrange the degree. The highest degree is 5. Therefore, you'll be writing negative 7x raised to 5 first. Next is 2. So, followed by plus 4x squared. Next is 1. So, followed by plus 6x. And lastly, the degree 0, that's plus 9. And there you have it. And what is the leading coefficient? The leading coefficient is negative 7. Let's go to example number 2. Writing polynomials in standard form again. So let's determine the degree of each term. So there you have it. The degree, the first term is 2. The second term is 6. And the third term is 1. So the highest degree is 6. Therefore, I will be writing y raised to 6 first. Followed by 2, which is y squared. And lastly, you have the degree 1 for negative 3y. So the leading coefficient is what? Correct. Take note, we have an invisible one there. And the leading coefficient is positive 1. Now, let's mention the missing terms. So you have there y raised to 6. What is missing here? Missing y raised to 5. Missing y raised to 4, missing y cubed, you have y squared, you have y, and the constant term. These are your missing terms. Okay? That's what you call the missing terms. Because the coefficient of your variable y is 0, 0, 0, and the constant here is 0. So take note of that. When the term is missing, the coefficient is 0. Let's continue. A variable written without a coefficient has a coefficient of 1. It's very clear. Now let's have this example. First, find the degree. So I'm going to be finding the degree here. 16 is a constant term, so the degree is 0. The degree of negative 4x squared, exponent is 2, so the degree is 2. For this one, the degree for this is 5. For this, the degree is 3. So arranging this, the highest is x raised to 5, followed by positive 9y cubed, 9x cubed, followed by the degree 2, that is negative 4x squared. And lastly, the constant term whose degree is 0, that's positive 16. And there you go. The leading coefficient is 1. Now, what about this? Arrange again. Determine its degree. Arrange now. So I'm gonna be having 8 start. There, ang 5, ang next. And then the degree 1 will be the last one. So the leading coefficient is negative 3. Now, some polynomials have special names based on their degree and the number of terms they have. So if the degree is 0, it's a constant. The degree is 1, it's linear. A degree 2 is quadratic. A degree 3 is cubic. A degree 4 is quartic. And a degree 5 is quintic. And if ever you have 6 or more, 6th degree, 8th degree, 7th degree, 9th degree. Okay? Now, if we will be dealing with the number of terms, if you only have one term, you call it a monomial. If you have 2 terms, you call it a binomial. If you have 3 terms, you call it a trinomial. If it's more than 3 terms, like 4 or more, you call it the general term. It's a polynomial. But these 3 are also polynomials, but they have special names. Okay? Now, let's classify each polynomial according to its degree and number of terms. So what's the degree in letter A? The degree is 3, correct? How many terms are there? There are 2 terms. So the degree is 3, and we have 1 and 2. There are 2 terms. So this is a, very good, a cubic binomial. The degree 3 is cubic, and it has 2 terms. It's a binomial. For letter B, what's the degree? The degree is 6, correct. And how many terms are there? There are 4 terms. The degree is 6, and you have 1, 2, 3, 4 terms for that. And take note, the degree is 6. You will be reading this as the 6th degree polynomial. Next, for letter C, negative 2x. What's the degree? The degree is 1. How many terms are there? You only have 1 term. So the degree is 1, and you only have 1 term. So this is a linear monomial. That's totally right. That's a linear monomial. For letter D, the degree is 4, and you have 1, 2, 3 terms. The degree is 4, and you have 3 terms there. This is 3 terms. So this is a quartic trinomial. Correct? That's a quartic trinomial. And for letter E, 7a raised to 5 minus 8. The degree is 5, and you have 2 terms. So this is a quintic binomial. That's totally right. That's a quintic binomial. Let's have more examples. It has a degree of 3, and it has 4 terms. So this is a cubic polynomial. For letter B, the degree is 0, and you have 1 term. So this is a constant monomial. That's a constant monomial. What about letter C? The degree is 8, and you have 3 terms. So that is an 8th degree trinomial. And there you have it. That's how you classify polynomials according to its degree and the number of